In this final part, we'll finish the iOS portion implementation. There are some methods that I've skipped entirely, so I won't discuss them here, but there are a lot of simple methods like we had in the Android port, which just delegate onwards. The getters are the simplest. They don't even need to enter the iOS thread. This returns the camera view, which should be initialized once start is invoked. This is a standard method in every native interface. Everything in between is trivial. The setters are a bit more verbose, but not by much. They are all practically identical, so I'll only focus on the first. I don't want to call update if the update didn't actually change. We update on the main thread by invoking the update methods from before. Notice I use the async call. As a rule of thumb, always use the async call unless you must use the sync call. It's faster and has a lower chance of a deadlock. In this case, I don't need the action to happen within this millisecond, so async will work just fine. I also have two special getters that need to run on the event dispatch thread. Normally this wouldn't be a problem, but when we need to return a value, that's a bit challenging. The block keyword allows us to mark the field as a field we can change from the lambda expression. Here is a case where we must use dispatch sync. If we used async, the return statement would have happened before we assign the value. Now all that is left is the actual capture method. The capture methods are a bit more complicated. Surprisingly, capturing a still image is a bit harder than capturing a video since the capture image method is a bit long. I've split it into two like before. This is a similar case of iOS 10 requiring a new API. All capture methods must run on the native UI threads as they deal with the native UI. Failing to do so leads to weird crashes. This is the new iOS 10 API. If it isn't here, we'll execute the iOS 9 compatible code. Up to this point, everything is pretty trivial. Delegate is a special concept in iOS similar to Java's interfaces. This means the current class implements the delegate. Before I go to the iOS 9 code within this method, let's look at the delegate. In order to implement the delegate, we need to make a small change to the header file. The delegates are declared in a syntax that's reminiscent of the Java generics syntax. I've also added the delegate needed for video recording while I'm here already, so that's two delegates. Now that these are in place, let's look at the delegate code. Delegate method declarations are huge. This goes all the way to the curly brackets. This makes Java's verbosity seem quaint. This is all just one delegate callback method declaration. This is an error, or the delegate was invoked because of a video event. We don't want to step into image processing code. NSData handles almost all I/O in iOS. It's similar to byte buffer in Java SE and allows us to map files from / into storage. I use NSData to byte array to convert the NSData object to a Java byte array. Notice that in the native code, all Java objects are effectively Java_object. I can now invoke the callback method with the given byte array. Notice the callback method includes the full name and argument types. The VM passes thread local context on the stack for every method. This makes things like stack traces work. For the code to compile, we need to add these declarations below the #import statements. The VM generates C code, so we can import it with include. The NSData2ByteR method is a method from the iOS port. I could have just included the whole header, but there is no need in this case. It makes the process of converting an NS data much simpler. Now that all this is out of the way, let's go back to the capture image class and the iOS 9 compatibility block. This is effectively code I got from Stack Overflow. I needed this since most samples are for iOS 10 Plus now, and ignore the legacy, but I still have quite a few iOS 9 devices that can't upgrade to iOS 10, so I'm assuming there is still some market for compatibility. Most of this code is boilerplate code for detecting the camera. No wonder it was removed. The capture image process is asynchronous and invokes the lambda expression below to process the resulting image. The rest of the code should be very familiar as it's almost identical to the one we used in the iOS 9 version. We just call back into Java. With this, image capture should now work for both old and new devices. All the basics should work with the exception of video. Capturing video is surprisingly easier than capturing still images. First, the simplest method is capture video. The no arguments version of this method saves to a temporary file name. We invoke the version that accepts the file with a temp.mov file path. The version that accepts a path isn't much harder. The AV capture movie file output class represents the recording process. We lazily initialize it. We bind the output value to the capture session. Now we can provide a URL from the file argument and start recording again. We use self as the delegate, which obviously leads us to the delegate method. Most of this should be very familiar now that we went through the image capture code. The callback accepts a path string, which we can translate from NSString using the from NSString API call. The last remaining piece is the stop video method. This is a trivial method if you've been keeping up. We just stop the recording and clean up. And with that last bit of code, we are done. I hope you found this useful. There is a lot of code to go through, but most of it is damn trivial once you look at it. You can create native interfaces that do just about anything if you have the patience to debug and Google native APIs.